All right, and we're back. It is COMP123 Summer 2016 semester at Centennial, and we're programming 2. It's week 7, part 2 of our broadcast. And again, this is the day we're doing review for our test, which is happening on the Friday of this semester. We just finished talking about lists and where to get information about lists. Again, it's kind of outside the scope of our book in actually the way we're going. It actually is in the book. If you actually would go to the book and look at it. It's just later on. They bring up generics later on. And actually, we talk about generics in programming 3 a little bit, right? So you have more of generics, more complex stuff like that in programming 3 that I'm getting you to use now because they're very, very popular. And when it comes to database access that we're going to be doing with the EF framework near the end of the course, right? You need to understand lists in order for us to use the EF framework. Okay, let's take a look at this thing. We want to make a new project here. So I'm going to say File. We're going to close this solution off, and I'm going to make a new project. So File, New Project, and I'm going to make template. No, we'll make it a new, no template. We're going to come up with a new console application that we're going to make the COMP123 Summer 2016 lesson 7. And the only reason why we're going to do this, let me make sure that it's kind of made correctly. Hold on a second, guys, or else you guys are all going to get mad at me because the GitHub repo is going to be all messed up. Here we go. Make sure I save it in the right place. And let us, I think that's good. Let's create this thing. Okay, so starting from scratch, got a programming class, and you know what? This is I want to create a new list. I want to make a list of numbers, and I want to have some random numbers. In order for me to use random numbers, I need one thing. I need a random object. There's two actual classes you're making you use, eh? The random class and the list class. Those two things that exist inside, and you need to do this for your test. Okay, so in order for me to use a random class, I need to use the random keyword. That's the class name, random. Right? I need to make a name for the random object called random. Oh my God. This is so unique, right? And then we're going to have to make it. How do I create an object? Come on, guys. Equals new random, right? Nothing crazy. Now there are two different constructors that you see here. See, there's two overloads right here. One, and it tells you right here in your IntelliSense. One is the empty constructor, right? And the other one, if you pull it down, gives you a constructor with a seed value. Why would I want to make a seed value? Why? Because if I seed it, I can make it so that it's a little bit more random. There is another random class that you can also use called crypto random, different kind of random class. We're not going to talk about that here, right? But there is another class that creates random numbers. Whenever we do random numbers, this is a pseudo-random number object. That's what it is, right? The pseudo-random number object means that when I create my random object, this one, right? This random number object accesses all the numbers that have been predetermined, right? I've got a whole list of numbers that I've predetermined, right? They've already been done for me, and all I'm doing is going to the next one, and the next one, and the next one, okay? So now when I want something like, for example, my random number, and let's say, for example, I want a random dice result between 1 and 6, right? So let me call this die 1, right? My first die. How about first die? First die. And I say die, I mean like it's actually like a d6 or some kind of die. My first die is equal to, example, my random dot, and if you see there's some options here. Next, next double, right? And some other things. If I go just next, I press open, you can see that there's three methods I can use. One, the empty constructor, right? And it says returns a non-negative random number, random integer, between 0 and 1, actually, right? And then here's one, int with a max value, returns a non-negative random number integer that is less than the specified maximum. So it does not include the maximum value, right? Okay, maximum value, the exclusive means it's not included, exclusive upper limit, basically upper bounds to this thing, right? That's the second one. And the third option is a minimum and maximum value. So minimum value, the inclusive lower bounds. So I want to make it go from 1 to 6, right? So what's my maximum value? The exclusive maximum value, 7. right? That's what I have to put in here. I can't put 6 because if I put 6, it will go up to but not including 6. So my range would be from 1 to 7, right? So this random number returns a value. Notice that first die, I need to define this as an integer, right? Or what if I use the var keyword? I can do that too. Both work. If I hover over it, it'll tell me that it's an integer because on this side it's an integer, right? We're not going to use var in this course. We're going to use int, right? Well, that's the first one. Okay, so I'm going to get a random number for the first die. And I'm going to do another random number for the second die. Right, random.next, 1 to 7. Okay, so a couple dies there. I could have made an array of dice. Please don't. I don't want to do that, right? And as soon as I do this, I generate the numbers, first die and second die, every time, first die and second die, all right? And then I want to show them what they are. So let's just for now, let's print them out. So we'll say our first die, so we'll use string interpolation. You have to use string interpolation. It's up to you, right? You can use string interpolation or concatenation. One or the other is fine for me. So first die, as an example. So first is equal to this, right? And this is first die. And then we're just going to copy and paste this as second. All right, so we're using random numbers first. Here's my second number, right? And first die, this will be second die. Right, so first die and second die, let's see what we get. So we're going to run this thing, Control F5, run without debugging, and we'll get two values. First one is 3, second one is 1. Okay, let's test it again. So 4 and 4. Okay, what about if we want to add them together? So there's the sum, or the dice, let's say, for example. I'll make another value. I'll say int dice, right, is equal to first die plus second die. And by the way, I can do this all in one line by not even having first die and second die, right? But dice is first die and second die, all right? The dice value. All right, so to calculate this, as an example, I can go console right line, dice result, or how about result? Result is equal to interpolated value, dice, right? So do that, it's S, Control F5, 7, right? At the 7. By the way, what's the average? The nearest average for two dice when you roll together between 1 and 6? It's 7 all the time. 6, 7, and 8 is the most common value. 6, 7, and 8, 6, 7, and 8, 6, 7, and 8, right? And the other values that are really rare are 2, it means 1 and 1, and 6 and 6. Those are more difficult values to get. If you look at the combinations and permutations of dice between 1 and 6, because I'm adding those two dice together, the minimum value I'm always going to get is 2. The maximum value is 12, right? Because I can add them up, get 2, 6, 6 and 6 is 12, and the minimum value is 1 and 1. But there's only 2 combinations of those. I have to get exactly a 1 and a 1, or a 6 and a 6, right? Whereas I can do 7 with 3 and 4, 4 and 3, 5 and 2, right? 6 and 1. Lots of combinations to get a 7. And because of that, 7 is the most common number. Okay? So this is cool. What I want to do is make a loop, right, to store a number of dice inside of a of a list, right? And I want to organize the the list and sort it, right, to show you how many combinations and permutations there are, right? So let's not do this, right? So we got this idea, dice, right, is the first die and second die. And what I want to do is I want to create a list. Here's my list. Here we go. I want to make a list of numbers. List, right, of integers, right? And in this particular case, we're going to call this dice rolls. Kind of like this, yeah, dice rolls. Dice rolls, why not? We can make it lowercase. Typically, we would do it like dice rolls, like this. And to complete it, I need to do a new list. Again, it's just an object of integers. But to fix it off, I got to use the open and close bracket. So this is a list of integers called dice rolls. Right now, the list is empty. All lists start off as just an empty container. There's nothing in the list. Whereas it's different than an array. An array has a set structure already. A list starts off as empty. There's nothing inside of it. It's just an empty container, an empty box, right? Now I want to add stuff to the list. So I want to do that every iteration. I want to roll the dice over and over again, and I want to add the dice result to the list because it's going to be an integer between 2 and 12. All right, that's what I want to do. So how do I do that? and how big is the list going to be? Well, I could create a constant value for the list, some kind of list value. Let's say I want to roll it 50 times, right? So I want a list with a, of 50, length of 50. This is where lists become really, really flexible, right? So I'm going to say the max int, our max rolls, right, is equal to 50, right? And what I'm going to do is I'm going to do this. I'm going to do a for loop that's going to be an index from 0 to max rolls, right? And what I want to do here is I want to take this stuff, cut it, and put it inside my for loop, right? So I generate a dice result every single time, and it's all done inside of my for loop. So I don't retain the values of my first die and second die, and even my dice value is gone. At the end of every iteration of my for loop, these numbers get destroyed, right? The variable lives and dies inside this code block, right? Okay, now I want to add my variable, add my dice result to the dice rolls array, dice rolls list. So how do I do that? I go dice rolls. I call the name of the list, dice rolls, and I use the add method to add in dice. Right? So I take the dice result, and I put it inside the list. That's all I'm doing it by using the add method. You're going to see this over and over again. Okay, so this is what loads the list up. All right. Now I want to show the list. Right. I want to show the list. So the way to show the list is using the for each loop. It's the best way to do it. Right? Because I can't use the for each loop here because there's nothing inside the list. Initially, the list is empty. So I can't use a for each loop. But when the list is full, like I have it right now, after this, the list will be full of numbers, right? And I want to show each of the numbers. So therefore, I'm going to use a for each loop, a different structure, right? And notice that the structure is a little bit different. Where it says collection, that's where you put the list. So the list name, which would be dice rolls. That's what goes in there. Item is the item that you're going to get from the dice rolls, the result, right? And var, obviously it wouldn't be the right number. It would be an integer, right? Each result from the dice rolls collection is an integer. They're all integers, right? So this is the correct method to use, right? An integer result. For every integer result in the dice rolls list, I want you to iterate. That's what it says. We're going to go through each item in the list, right? Okay, let's take this out. So how do I do that? I want to say something like this. I want the console write line, right? The result. So here's my result, right? Plus, I want to add in a space, right, for each of the items. Okay. If I do this, and it keeps iterating, because I'm using a console write line, it's going to actually add lines down like this. If I want to make it to add console write, so it kind of lists across, it'll be just console write. And at the end, what I can do is I can do a console write line. Okay. And so that's going to display each item in the list. Let's see this. And you notice that this is a lot leaner than this. This builds the list. By the way, there's going to be a build method that I'm going to get you to make. Build. It's going to build a list up, whatever I'm going to do, right? And then this is going to display the list. And we can display the list with a for each loop, typically. All right? All right, so let's see what that does. Control F5. And you can see that I got a bunch of numbers. 738, 762, 4387. And they're numbers between 2 and 12. Right? There should not be a number that's less than 12 or less than 2. And if there is, like this one looks weird. Is that a 1 or a 12? That's weird. We should never get that number, right? If we get a 1, something's wrong with our random number generator. It means we get a 0 somewhere, right? Which is impossible. Oh, there's no scroll. I swear there isn't. Oh, here you mean. Okay, Smarty. Yes, so we didn't get anything weird. So we got this really weird list of values. Let's sort the list. All right, so how do we do that? Before we print, I want to sort the list. So how do we do that? We use the sort method. So we say our list, which is dice rolls, right? Dot sort. This sorting method, what it does, if you hover over it, it sorts the elements in the entire list using the default comparer. The default comparer basically does from lowest to highest, right? It doesn't allow me to do, I go sort, notice that I have 4 overloads for the sort method, right? Sorts the elements in the entire list, default compare. What's the next one? I can use an iComparable, right? I can create my own comparison operator. The other one is another integer comparer, or the fourth one is some kind of index. So it sorts the elements and range elements of the list from an index to how many? 5 elements. And then with my default, with my comparer that I have to create. This is more complex, these 3 other ones. The only one I care for you to do is this first one, the empty constructor, which is a default comparer that's built in. Let's see what it does now when I print it out. Does it work, first of all? And you see that it does. It organizes everything in numeric order from least to highest, least to most, lowest to highest. Okay, so that's sorting lists. Notice that I only got 1, 2, and this whole, and 50 rows, and 1, 2, 3, 4 12s, where I got lots of 7s, actually not that many 7s, but lots of 6s and 8s and 7s. That's the most common number, 6s and 8s and 7s. That's your distribution. And if you want to do a larger example, this is where lists are awesome. Okay, here's where lists are awesome. Let's make this into 50,000. Yeah. Right? It's gonna crash? No way, man. Bam. Right? It's a big list, and it'll keep going. You can see where all the 8s and 9s and distribution is for the 12s, right? Okay, here's a question. What if I want to keep track of how many do I have? How many 7s, how many 6s, how many 5s, how many 4s, how many 3s, how do I keep track of that, right? It's not that difficult. I could create a list again, right? Each list item could have, you know, as an example, values, right? But I want to tally. I want to be able to tally how many of each of these things, these values, right? Well, this is where I would use an array instead. See, an array is immutable. It stays the same. I'm always going to have an array between 2 and 12, which means I can make an array element that I can look at array number 2, and I want to go to the array element number 12, which means I'm going to make it from 0 to 13. Follow me here, right? I don't care about 0, 1, and 2, right? Or 0, 1. I don't care about those values. I'm going to leave the array 0, 1 of the array empty. But from 2 to 12, every time I have a 2, a 3, a 4, a 5, a 6, 7, 8, 9, 10, 11, 12, I'm going to add 1 value to my integer array. That's what I'm going to do. Let's try this out. This is where the difference between lists and arrays. So now here's my dice rolls. I'm going to make an integer array, right? So integer array, I'm going to call tally, right? Which is equal to a new integer array of 13 values. Okay, notice that I'm not instantiating the object, right? I'm using the new keyword because an array is a complex object, right? Okay, cool. When I do this, it's instantiated already. So what I'm going to do is this. Depending on the number that I get, from 2 to 12, whatever the dice result is, I'm going to add to that array, right? Now, initially, each of the integers by default, what are they? Is there as default 0 value? And the answer is yes, they're all zeroed out at the beginning, right? Because the default integer value is 0, right? That helps us because then I can do something like this. I could say tally, and whatever the dice result is, right? Dice result plus plus. So here I can tell you how many, right? What's the number? Initially the value starts at 0. And now I'm just adding 1 to every time. Every time I get a dice result, I'm going to add a number. And then I can read the values of each of the numbers of my array based on you know, the value. So for example here is I've got my list. I'm printing it all out. Crazy number of lists. But I want to basically print everything in my array. In my array, I need to use a for loop. So for index is equal to 0. That's cool, right? I don't want to start at 0. I want to start at 2, right? to less than 13, right? Which is the maximum size of my list. So 2 to 13, so 2 to 12, right? Index plus plus. And what I want to do here is say something like this: console write line. And then it'll be the name of the item, the index number, right? Index number, colon, and then how many that I have, the index value, which is my my tally, right? And then the index that I want to show. Oops. Tally index. So it's going to show me for one, how many twos, how many threes, how many fours, how many fives, how many sixes, right? That's what it's going to be. Let's see that and see what I'm talking about here, if it works. Right, finishes, and at the end, I get a bit of a tally. That goes away. Let's try that again. I should have done it this way. So it calculates 50,000 rolls, right, of my dice, and it's going to show me the analysis at the end. So I should have had a space, but 388 ones, 777 twos, and so on. Let me try and go that again, because that didn't work exactly how I wanted. I probably want for 0, how many there are, right? And then, because this just tells me how many, right? It's my tally index, right? So what I want to do is, for the tally, for the number, how many? Which means 1. So the index value is what I really wanted here, index, and then comma, my tally, right? There we go. Let's do it again, because I'm crazy, right? See if 50,000 rolls, clickety-clack, right? And it sounds like a lot of rolls, but actually a computer can handle it nicely, right? Now here's the difference. So 1,361 twos. Look at the distribution of sevens, 8,358 sevens, right? And so you can see that the lowest amounts, and this is exactly how it should be, are the 12s and the 2s. The 12s and the 2s are the lowest amounts, and the highest amounts are the 6s, 7s, and 8s. That's where I have the most distribution. So that shows me that my random number generator, my pseudo-random number generator, is working correctly, right? That's how I would do a tally of numbers. Questions around this, right, what I did. So I used both the array and a list. But the array makes more sense in the second case because my array is fixed. My array is not going to change. It's going to have 13 elements. My list, though, I can make this number whatever I want. And probably a smart thing to do if I'm going to make it really big, instead of displaying the list, let's not, right? I'm just saying, you're going to display the list. I mean, you're going to do some kind of crazy big list and sort it and everything else, right? Let's not make it like that. Let's use 5 million. Like, 500, that's 50,000. That's 500,000. That's 5 million. Let's see how fast it runs 5 million without printing everything out, right? So I started off, and then done. 5 million, right? So you can see that the biggest distribution, the more sample size you get when it comes to analysis, the more accurate it becomes, right? For example, for sevens, there's 832,000, right? Sevens, 832,770, right? Or whatever. Whereas there's only 138,000 for both 2s and 12s, right? Almost exactly the same number. So the distribution is actually quite rounded. And same thing with, if you look at 4 and 10s, there are 416,000 or 417,000. And 5s and 9s, 5s and 9s, 55,000, right? And 6 and 8s. So this gives you the exact, almost like a bell curve, if you will, of distribution. The bell curve happens at both ends. 2 and 12 is the least amount, and the middle 7 is the peak. Okay. So a very small example, but it handles everything that you need for your test, believe it or not, right? If you know how to do lists like this, to describe a list, if you know how to do, and that's why lists are so flexible, I can change this number whatever I want. I mean, I could have done it with arrays as well and change this number, but the great thing is this will never change. My array, I'm always going to tally between 2 and 12. That's why this is a good scenario for an array. My array is not going to grow. It's going to be a fixed size. I have a couple of elements, though, to be honest with you, that I'm not using, 0 and 1. I don't care about those ones, right? My array is using 2 to 12, right? The rest I don't care about, and I'm tallying here inside my, inside my iteration. Every time I iterate, I add to the number tab. I'm tallying every time I roll a result. Every time I roll a dice result, I'm tallying that result because I'm using the index as the place in the array that I'm going to add to. Right? A little bit of an algorithm. I know people don't like algorithms. Algorithm's a dirty word in computers. Oh my God, an algorithm, right? But this is very, very simple. Questions? So we've covered classes and objects, inheritance that you need to know about. I've kind of given you everything, the direction you need. Now it's about putting all that together. This is the tough part to make them where the test is hard. Putting it all together to make something work, right? I've asked you to sort, and I'm telling you the sort method for lists is the easiest way, right? How about remove? If I want to remove an object, how do I do that? Like, for example, I want to remove an item from the list. I use the remove method. It's very simple. I just name the method, remove, and whatever item I'm removing. Now, how do I know what I'm removing? Like, for example, if I want to remove an item, it's not the same as what I'm doing. If I go dice rolls, right, remove, right, I have to kind of say, what's the item name? Like, it's an integer item, right? So that's kind of funny. But what about if I remove at? And which we're going to do more often, right? Remove at, and then give me the specific index that I'm removing. Why would I want to do that, right? Because it's going to be on your test. That's why. So remember, if I ask you to remove something on the test, chances are, please use remove at. That's going to solve your problem. Use remove by itself, it's not going to solve your problem. It's more, it won't do what you want it to do. Remove at, though, tells me there's a specific index that I want to take care of. For example, if I want to get rid of the first number, it's remove at 1. Or the second number, Remove at 0 takes away the first one. Pops the first one off the top of the list, right? But I'm going to ask you to do this in a random way. Imagine if I had a random number, one of these numbers is randomly going to come off. Then I would take a random result and put it there. So remove at is the only one I'm going to make you use for the test. Remove at, add, and sort. Okay? Questions around this before the test for Friday? Guys, have a great one, and we'll see you Friday. Please come on time. I'm going to start right on time.
We have to make the results for you.
Hold on. Yes.